Welcome to the podcast, where we dive deep into the fascinating world of machine learning. Today, we're going to explore some pivotal concepts and tools that help machines learn and make predictions, as outlined in a structured curriculum on machine learning topics. I know it sounds a bit technical, but don't worry, I've got some interesting insights to share that will make this journey engaging and relatable. Let's kick things off by talking about naive Bayes and k-nearest neighbors, or KNN. Now, if you've ever wondered how spam filters know what's not worth your time, naive Bayes is one of those algorithms that helps make that happen. It uses probabilities based on features of the emails, like specific words or phrases, to classify messages into spam or not spam. And then we have KNN, which is like having a group of friends weigh in on a decision. Imagine you're trying to decide what to wear based on what your friends typically wear. You'd look around at who's nearest to you, check their outfits, and decide based on that. In machine learning, KNN identifies new data points by looking at the K nearest examples in the dataset. Pretty intuitive, right? As we move through the curriculum, we dive into linear regression and linear classification. Here's a quick analogy. Think of linear regression as drawing a line through a set of points on a graph to find the best fit. It's all about predicting a continuous outcome. On the other hand, linear classification is like being at a party and trying to decide who's going to be a fun dance partner. It's more about classifying people into distinct groups based on their dance moves, or in machine learning terms, their features. Then there's support vector machines, or SVMs, which take that idea of classification up a notch. Picture two groups dancing at opposite ends of the room. SVM finds the ideal barrier, or line, that maximizes the distance between the two groups. The goal is to create the best possible separation, allowing our model to confidently predict which group new dancers belong to. Now, to spice things up, we move into gradient boosting. Imagine you're trying to bake the perfect cake. The first one turns out okay, but maybe it needs a little more sweetness. Instead of tossing it out and starting over, you tweak that recipe a bit. Gradient boosting does something similar by creating several models, building on the weaknesses of prior ones until the final one is quite robust. Oh, and how can we forget deep learning? It's like the internet's magical toolbox for understanding images, sounds, and text. Think of it as the ultimate AI brain that mimics how humans learn. Just as we absorb knowledge through experience, deep learning algorithms process vast amounts of data to recognize patterns, like having a friend who can instantly spot the best ice cream flavor based on what made you smile last time. As we wrap up today's discussion, let's reflect. We've journeyed through a variety of significant machine learning concepts, from the simplicity of linear regression to the complexity of deep learning networks. Each of these tools serves a unique purpose in helping machines decipher the world around them. Before we sign off, I want to leave you with this thought. As technology grows, so does our understanding of its capabilities. How do you envision using machine learning in everyday life? Well, that's it for our episode today. Thanks for tuning in, and I hope you learned something new. Until next time.